Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Tetromino Sudoku by Senny K. And here are the rules. We have Tetromino, where we need to shade some cells in the grid to form tetrominos, which are blocks of 4 cells, which cannot be orthogonally adjacent and must form a diagonally contiguous area. Two tetrominos which touch each other at the corners must have different shapes, counting rotations and reflections as the same. And additionally, no 2x2 region is entirely unshaded. So what does this mean? Tetrominos cannot cut are basically 4-cell blocks, which could be like, I think the ones are an I, there's an L, there's a J shape, so there's I, L, J, T, N shape. Is that N? I don't remember if that's N. Z. Which one's Z? Z's, yeah. I think this one's Z. And then there's the square. So those are the 4 tetromino shapes you can have. But it's actually less than that. The L and the J are considered the same because counting rotations and reflections as the same. So this is the same because you can reflect it and it will be exactly the same as the L. This Z is the same as the N because if you reflect it, that will be the same cell. So you cannot have them sharing an edge with each other. So you cannot have tetrominos sharing an edge with another tetromino, shaded cell. Because they cannot be orthogonally adjacent, which means sharing an edge. And they must form a diagonally contiguous area. So that means all the shadings in the cell must be touching each other, must be touching at least one other tetromino by a corner. That's what it means to be diagonally contiguous, I guess. Also, 2 tetrominos which touch each other at the corners. Remember, they can't touch each other by the edges, but you can touch each other by corners. So, and in fact, you have to, because you have to share a corner with at least one other tetromino in the puzzle. So 2 tetrominos which touch each other on the corner must be different shapes. That includes rotations and reflections. So again, as I said, J is the same as L, N is the same as Z. So you essentially have 5 different types of tetrominos you can have, and two of them of the same type. So you could not have something like I'm trying to think of something here. You could not have something like, I don't even, that would be another L. So just remove this. You could not have something like this here, because this is an L and this is a J rotated, but if you reflect it, obviously it's the same thing, right? So then this is not possible because these are the same shape for tetrominos. And there's also no 2x2 area that is entirely unshaded. So there must be some shading somewhere in every 2x2 box in this puzzle. So that's how tetrominos work. We have Kropki dots, where cells joined by a white dot are both unshaded. So that would not be valid there if I try to have that, because these must both be unshaded. And cells joined by a black dot are both shaded. And cells joined by a gray dot are one unshaded and one shaded. So this is valid for this because this would be unshaded, this would be shaded. Same with this, same with this. However, this doesn't work because both of these are unshaded. This doesn't work because both of these must be shaded. And that's how it worked for tetrominos. And finally, we just have Sudoku rules, where normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. Killer. Digits in a single tetromino may not repeat and sum to 23. So for every tetromino, the digits in them cannot repeat and they sum to 23 exactly. Kropki dots. Digits in cells joined by a white dot are consecutive. Digits joined by a black dot are in a 1-to-2 ratio. That is, one digit will be double the other. Not all dots are necessarily given. So, for example, if this were, say, a 2, not a color, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1-to-2 ratio between them. If this were, say, a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. And those are how Kropki dots work, or examples of how Kropki dots work. And finally, we have XV, where digits in cells joined by an X sum to 10. Digits in cells joined by a V sum to 5, and not all X's and V's are necessarily given. So, for example, if we had, say, a 3 here, this would have to be 7, and this would have to be 2. Because these two digits must add up to 10, because there's an X between them, and these two digits must sum up to 5, because there's a V between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So these are both shaded. These are both shaded. These are both shaded. These are both shaded. We're going to color the unshaded as green. So these are all unshaded. These are both all shaded. Shaded. This is unshaded. 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 And unshaded. So again, the gray dots have one unshaded and one shaded. So this must be shaded here. This must be unshaded here. This must be shaded, so that makes this unshaded here. Any digit that is in a 1 to 2. Okay, so we have a 2 by 2 area that is all unshaded. So you that is 3 unshaded, so this can't be unshaded, this is shaded. This is 3 cells this way. If it connects to this, the problem is that would not be a tetromino. So these cannot be shaded, they have to be unshaded. Because if they were shaded, if either one of them was shaded, it doesn't form a tetromino. It forms a 6-length thing. This has to be 2 or 4 because the only digit which is in a 1 to 2 ratio with 2 other unique digits is specifically 2 and 4. 2 being with 1 and 4, 4 being with 2 and 8. Either way, we are guaranteed in these 3 cells, it must be a 2 and a 4. Which means the rest of the row cannot contain 2 or 4. So this cannot contain 2 or 4. To add up to 5, it's 1 or 3 with 2 or 4. To add up to 5. This again is 1, 2, 3, 4. To add up to 10, this is 6, 7, 8, 9. This is 1 through 4, 1 through 4 here. These are 1 through 4. To add up to 5, to be in a 1 to 2 ratio, it's everything except for 1 and 2. Because if it were 1, 2 as a pair, 1-2 in a 1-to-2 ratio, that would eliminate 1-4 and 2-3 as possibilities here. So this has to be 2, 3, 4, 6, or 8. We are guaranteed this is either 3, 6, or 4 with 2 or 8. So a 3 or 4 is here, a 3 or 4 is here, which eliminates 3 and 4 in the rest of the column. So we have 1, 2, 5, 6, 7, 8, 9 in the remaining digits in column 9. And this can't be 2 because of 2, 4 guaranteed in one of these 3 cells here. 1, 2, 5, 6, 7, 8, 9. This can't be 2 and 4. If that were 2 and 4, you'd have the same problem here. So this can't be 2. This is 3 and 6 or 4 and 8 here. This is a 1-to-2 ratio. This could be part of... Okay. This must form part of a Tetromino. So it has to exit out here. It has to have 4 cells. This cannot be 1, 2, and 4. Remember, the Tetrominos must add up to exactly 23. So this must be 4 with 2 and 8. What does that form? So this is 4, which makes this 2 or 8. So 4 eliminates 4 here, so this can't be 8 here. 2 and 8 is 10, plus 4 is 14, plus 9 must add a full tetromino. So this must be 9. This can't be 9 here, so this must be 9 here. So this is shaded. So this cannot be an L. So if this were shaded, that would form an L or J, both of which are the same type of tetromino there. So this has to be shaded, unshaded here. This is shaded. Oh, sorry, unshaded, unshaded here. Since this is unshaded, this must be shaded here. This must exit out that way. This cannot just go out that way because it's the same shape if you rotate it. If you, sorry, mirrored it. What was that? What was the term? It wasn't mirrored. Reflected, right? If you reflected it. So it cannot go that way. It can't be long because that would then be a 6-length tetromino, which is too large. So it has to be a T. So this is T, which makes this green. So since this is green, this is the rest of the tetromino here. This can't be tetromino, so it's green. This is 9, which eliminates 9 in the rest of the box. This can't be 8 because of 2 8 pair in the row. These are consecutive. So this is 1 through 5 here. I don't know how I included this one. This cannot be 2 or 4 because of the 2 4, the 4 in the row and the 2 8 pair in the row. So this is 1 3 5, which makes this 2 and 4 here to be consecutive with that. That means this can't be 2 or 4. This is 1 or 3 with 7 or 9 to add up to 10. This is also 1 through 5 here as possibilities. So, let's see. This must go 4 this way. So this is done there. This is green. This could be multiple things here. This cannot connect here because that's a 5-length tetromino then, if that's the case. Same with this. So this cannot be shaded. Therefore, this is shaded here to be next to the gray spot. These can't connect, so this must be green there. Um, okay. This must exit out as part of a tetromino. The problem is we don't know what this is. This adds up to, this is either, there's many combinations, that's not worthwhile to do that. These are consecutive. At least one of these is blue, but that doesn't tell us very much. Remaining digits in row 8 are 1, 3, 5, 6, 7, 8, 9. Okay. Hmm. 9 cannot be either of these, so 9 has to be one of these two. So to add up to 23, we are guaranteed a 9. 23 minus 9 is 14, so the other three digits must add up to 14. Okay. Not too helpful there. What can these digits be? So these are the same in a sense. 1, 9, 2, 8, 3, 7, 4, 6. No 4 here, so no 6 here. No 9 here, so no 1 here. To add up to 10. This can't be 7 because that's not in a 1 to 2 ratio with another digit. So this can't be 3. So this could be 1, 2, 4, 8, or 6 here. This must add up to 23. If you have 3 and 6 here, so 3 and 6, that's 9. Plus 9 is 18. Plus 4 at most is 22. So this cannot be 3 and 6. It must be 4 and 8. So this is 4 and 8, which means this is not 8. This is 2. This is 8. How did I have 8 here? Anyways, 8 can't be any of these digits. So this is 4 and 8, which forces this not to be 1 or 4. This becomes a 2, 3 pair, which eliminates 2 and 3 and 8 in the rest of the column. No, 2 and 8. This is already 12. 12 plus 2 and 9 add up to 23. 12 plus 3 and 8 would have to add up to 23 there, which is not allowed. So this is 2 and 9. So we have 2 and 9 here. This is 3. That eliminates 3 and 7, adding up to 10 in the rest of the box. And this can't be 3 or 6. There's no 2 here. To be in a 1 to 2 ratio, it cannot be 1, 2. It's 4 and 8. So this is 4 and 8 here, which eliminates 4 and 8 in the rest of the box. Also, this can't be 2, 4, 8, or 8. So this must be 1 and 9, adding up to 10. 4 and 8 are with 2 and 6 here. This 1 and 9 eliminate 1 and 9 in the rest of the box. So this is 5, 6, or 7 here. 1 is guaranteed to be one of these digits. If we have a 1 with 4 and 8, that's 13, and the other digit's not going to work. So this cannot be part of this tetromino. So this is green. That makes this blue. So this must exit out, so this must be a full-length blue. That's done as a box. So this can't be connected to any, can't be orthogonally connected to any other tetromino. This could be a square. 12 plus 11 does add up to 23. Remaining digits here add up to 14 without a 9, so we have a similar situation, and we don't have 4 available. What are the remaining digits in column 8? We have 3, 5, 3, 5, 6, and 7. So these two are consecutive, so it must be 6 with 5 or 7. So there's no other 6 in the column, and 3 has to be one of these two. No 6 here, no 4 here, no 2 here. So no 2, 4, or 6. This must be an even set here. Right? 23 minus 9 is 14. So this is even, which means for 3 digits, 1 has to be even and 2 has to be odd. You can't have 3 evens because 4 and 6 are no longer possible here. So you have to, and you have to have an 8 here. So this must be 8. That's 17. It's 1, 5, or 3, 3. It can't be 3, 3, obviously. So this is 1, 5, 8, which eliminates 1, 5, and 8 in the rest of the box and column. So this can't be 1, 5. This can't be 5. This is a 6, 7 pair, which eliminates 6, 7 in the rest of the column. This can't be 5 either because of 1, 5, 8 triplet in the row or in the box. So this is 3. This is 5. That eliminates 5 from being here. So 5 has to be one of these two digits here. This then... 5 eliminates 5 here. This can't be 3 or 4 because of 3 or 4 in the row. So this is not 1 or 2 to add up to 5 here. Therefore, this can't be 4. This is one of these is guaranteed to be a 2. We're not sure which. Also, one of these is guaranteed to be 1. Because if this is 2, 3, that means this can't be 3. If this is 1, 4, this is 2. So this can never be 3. This is 1 or 2. So this is a 1, 2 pair here. That means we have in box 7, either this is 1 or 2, or this is 1 or 2. That eliminates 1 and 2 in the rest of the box and row. So this can't be 1 here. This can't be 1 or 2. We could have 3, 4, 6, 7, or 9. But if this were 3, 4 as a pair, this can't be 4 or 9. This is 3, 6, or 7 as possibilities here. The problem is if this is 3, this can't be 4, because then that would eliminate all possibilities for this V. So this can't be 3 or 4. It's 6 or 7 with 6 or 7, which eliminates 6, 7 in the rest of the row. So this has to be 9 here, and then that means this can't be 9 here. This can't be 6, 7 because of the 1, 6, 7 triplet in the box. So this is 3, which is consecutive with 2 or 4. So this is 2 or 4. 6, 7 is consecutive with 5, 6, 7, or 8. There's no 8 possible in the because of the 8 in the column. This is a 2, 4 pair, which eliminates 2 and 4 in the rest of the box. This can't be 4. This is a 3, 9 pair, which eliminates 3, 9 in the rest of the box. So this can't be 3. This is 1, this is 2, this is 4. No 1 or 3 here. This is 5, 6, and 7 as possibilities. We know we have a 5 guaranteed here. 3, 9 eliminates 3 here. So this is 1 and 4 adding up to 5. 1 and 9 add up to 10. 1 eliminates 1 here, so that's 2, which makes us 1 and 4. So we have 1 and 9 here. The other two digits must add up to 13. 23 minus 10 is 13. You can't have 9, so no 4, 9. It's either 5, 8 or 6, 7. We're not sure which. This also adds up to 23. We're guaranteed 2 and 5 here. 2, 5 add up to 7. Plus another 7 would be with 9. Wait, that's not right. Oh, this is 1 and 4. How did I do that? Okay, that's all wrong. Okay. That still has to be 6, 7, so that eliminates 6, 7 there. This is 3 consecutive with 2 or 4. 2, 4 as a pair eliminates 4 here. So then this can't be 3. This is 1 and 4, which makes that 2. Okay, so that's the problem. This again, still 5, 6, 7. You cannot have 1 here. There's no 1 here. There's no 3, 9 here. This is 5, 6, 7. So 1 cannot be here. We have a 6, 7 pair in box 9, so this is 1. So this is 2, 6, or 7 here. This is 5 and 4. So 4, 5, and 6 with 8 works. 4, 5, and 7 would add up to 16. 23 minus 16 is 7. So you'd have to have 2 7s here, and there are no repeats allowed on Tetrominos. So this is 4, 5, 6, and 8. So this is 8. This 3, 9 pair again. This forces this 1 and 4. This is 2. That's 1 and 4. This is 9. So 9 cannot be here. 9 has to be here. So this can't be 9. This is 10. It has to be, cannot be 5 and 8. So this has to be a 6, 7 pair adding up to 13. With the 1, 9 adds up to 23. That means this is 3 or 5 here. This can't be 3 because of 3 in the row. So this is 5. This is 3. 5 eliminates 5 here, so it's 6 and 5. 6 eliminates 6 here, so it's 7 and 6. 6 eliminates 6 here, so it's 7 and 6. 6 eliminates 6 here, so it's 7, which is consecutive with only 6 here. This 7 eliminates... This 6 eliminates 6 here, so this is 2 and 8 adding up to 10, which makes that 4. There's no 7 here. This can't be 2 or 6. This has to be 7. Okay, this is in a 1 to 2 ratio, so it's either 1, 2 or 3, 6. Well, 1 can't be here, so this can't be 2. 6 can't be here, so this can't be 3. Okay, if you have 4, 7, and 8, that adds up to 4 and 8 is 12 plus 7 is 19. 23 minus 19 would be another 4, so that's not possible. So this cannot be part of this tetromino. So this is green. These are both blue. And 5, 6 as a pair works. Remaining digits in column. This can't be 1 because of 1 in the row. These are consecutive. No 1, no 9, no 6, 7, or 8, so it's 3, 4, 5. This can't be 3. One of these is guaranteed to be 4. We have remaining digits in column 6 as 1, 3, 4, 5, and 9. This can't be 4 or 9. It's 1, 3, 5. 1, 3, 4, 5, 9. 1, 3, 4, 5, 9. No 4 here, obviously. So 9 has to be one of these 2 digits here. This is in a 1 to 2 ratio. Cannot contain 6, so it's 1, 2, 4, 8 here. 1 can't be here, 2 can't be here. 1 to 2 ratio, no 1, no 6. We are guaranteed a 4 here. So 4 cannot be here because of 4 in the row, so 4 has to be here, and it's with 2 or 8. This then cannot be 2 and 8 adding up to 10, cannot be 4 and 6, cannot be 3 and 7 because of the 3, 4 in the column. So this is 1 and 9. Hmm. This can't be 4 because of the 4 in one of these two cells. Remaining digits in column 1, we have 3, 5, 6, and 8. No 8 here, no 3 here. 3, 5, 6, and 8. Okay. Interesting. Can this ever be 1? 1, 4, and 8 add up to 13, so another digit would be 9 at max, and that would be 22. So no, this can't be 1. This has to be 9, which makes this 1. This can't be 1 and 2 in a 1 to 2 ratio, so it's 3 and 6. No 3 or 6 here. No 1 or 3 here. This can't be 6, so this is 5, which makes this 6. 5 eliminates 5 here, so it's 9. And it eliminates 5 here, so it's 8, which forces this to be 2, 4, 9. No 9 here. No 3 here because of the 3 in the box. No 8 in these cells here. This can't be 6 because of 6 in the row. 2, 4, 9 add up to 15. 15 plus 8 adds up to 23. So this has to be part of it here because it can't connect to any other cell. So these are not shaded. This could be shaded here. We're not sure. Okay. Remaining digits in row 2. We have 1, 3, 5, and 7. And no 3. This is a 1, 5, 7 triplet, which eliminates 1, 5, 7 in the rest of the row. This can't be 5. This is 3. This can't be 3 then. This 1, 5, 7 triplet eliminates 1, 5, 7 in the rest of the box. So this can't be 5. This is 4, which eliminates 4 here. That means this can't be 4 here, which means this can't be 8 there. This is a 2-8 pair. Remaining digits in row 3 are 5, 6, and 7 then. Okay. Can you ever have 1 and 2 be 2 cells next in the 2 shaded cells of a black Kropke dot? And I think the answer is no. 1 and 2 plus 2 digits is never adding up to 23 because 23 minus 3 is 20, which 2 digits can't be. So this is 4 and 8. 4 and 8 here, which forces this to be 2. Okay. 3 and 6. Say we didn't have the 9 here. It would have to be, it could not go down to here. It would have to be these two. So 3, 6, 5, 7. Would that, this can't be 1. Remaining digits in row 6. We have 2, 5, 7, 8. No 5 or 8 here. No 2 here because of digits in the column. 3 eliminates 3 here. So this is 9. This is 3. This can't be 8 here. Remaining digits in column 2. Oh, 5 and 6 here eliminate 5 and 6 here. So this is 7. This is 6. This is 5, which makes this 6. Remaining digits in column 2 then are 3 and 8. Remaining digits in column 3 are 2, 5, and 7. This can't be 2 because of 2 in the row. This 6 eliminates 6 here, so this is 7, which makes this 6. 7 eliminates 7 here, so it's 5, which eliminates 5 here, so it's 3. No 3 here. 3 eliminates 3 here, so that's an 8. That's 3. This can't be 5 or 8. It's 1. No 1 here. This 5 here eliminates 5 here. That leaves this as a 9. This is 1, 2, or 7. In column 4, in column 5, it's 5, 7, or 8. Okay, so now we try to figure out these tetrominos. Again, if you have 3 and 6, 23, so if we don't have a 9, so 3 and, okay, 23 minus 9 is 14. With 3 and 6, it has to be 5 and 9, so 9 has to be here, and one of these is 5. 8 and 4 is 12, so the other two must add up to 11. This can't be 5 here. Yeah, 11. So it cannot have 3 and 8, cannot have 4 and 7, so it's either 5, 6, or it's 2, 9. Well, if it's 5 here, it can't connect to a 6 without being shaded. That's unshaded. So this cannot connect to there. It must connect to the 9. So this is unshaded. Well, yes, this is unshaded. Sorry, this is, yes, unshaded. And this 9 has to be shaded, and we can connect to a 2. So we connect to a 2 here or a 2 here. We're not sure. This has to be orthogonally connected to another, sorry, not orthogonally connected, diagonally connected to another shaded. At least one of these is shaded. So if we had 2 here, at least one of these is shaded, but then the problem is this is already a tetromino, and then this wouldn't be able to form a tetromino. So it cannot go this way, it must go this way. Since it must go this way, this cannot be shaded, so this must be shaded there. So this is 5 and 9, with 6 and 3 adding up to 23. Right? 5, 6, and 9 add up to 20 plus 3. Therefore, this is 7, this is 1. 5 eliminates 5 here, so that's 1. No 1 here. This is 2, 7 as a pair. No 7 here. Neither of these can be shaded because this has to be shaded and must exit out this way. So both of these could be shaded. We have 1, 2, 3 guaranteed here. Could connect here. So this is 2 and 7. That's 9. If we add just 3 here, that doesn't work. Oh, you can't have repeats. 8 and 3? That doesn't work. Huh. Ooh. One of the... Okay, so this has to be shaded. This has to be shaded. This has to be shaded, and it can't shade that way. Because then we'd have a repeat here, guaranteed. So it has to go there, but that's too small. Hmm. How does that work? Everything else looks kosher. We can connect this. But this is guaranteed to be 9. right? And 9 plus 8 plus 3 is only 20. How did I mess this up? Uh, hmm. Might have to go back. Just uh, so again, 1 and 2 cannot be the shaded cells, next to a Kropke dot. This is shaded. This is not shaded. So this must exit out. 2, 4, and 8 is 14 plus 9. These can't be shaded. So it has to be shaded here, which means this is unshaded here. This is 9, 4, 2, and 8. This can't be 2 and 1. No 2. So could it be 3 and 6? It could have been 3 or 6. Except what? Yeah, this is 2 and 8. 1, 3, 2, 4. No 2 or 4 here. This is 1, 3, 5 to be consecutive with 2 or 4 here. 1 through 4, 1 through 5, 6, no 6 or 8, 7 or 9. 1 through 4, this is shaded. 1 through 4 here. Again, no 1, 2 here. 4 could be here with 2 or 8. Can't be 4 and 2 because that would eliminate all possibilities for that. So it's 4, 8, or it's 3, 6. This is shaded because of 2 by 2 area that is all unshaded. If it goes here, these are the same shape. That's not allowed. This is green. This is blue. This blue must go out. Cannot go out that way. Can't go full there. So it must just be here. Which means this is green. That's blue. This is green. This can't go that way. So this must go forward that way. If this were 3, 6, this would be at most 4 and 9. 3, 6 is 9 plus 9 plus 4 is 22. Oops. These are not green. These are both blue. So this is green. Therefore, this must be 4 and 8. Which makes this 2, 3 as a pair. 3 would have to be with 8 here to add up to 11, so this must be 2 and 9. Forces this to be 3. No 1, 2 as a pair, so we're guaranteed a 4 here. So 4 with 2 or 8 here. This is blue, so this must be green here. This can't, well, So this is 2, 8, or 6 here. We have a guaranteed 4 here. Remaining digits in this column are 1, 3, 5, 6, 7. No 3 here, no 5 here, no 7 here. The problem is, again, this has to be consecutive. You need an even digit here. So it has to be 6 with 5 or 7. This can't be 3, 6 because of a 3 in the column. No 1, 2 is possible to form a tetromino. So this must be 6 here, which means this can't be 6. This is 1 and 9. Again, if we try to form a tetromino here as blue, that would be 1, 4, and 8 at max, which is 13, which doesn't add up with another digit to add up to 10. So this cannot be blue. This is green, which forces this to be blue. Blue has to exit out. So this is blue, and this is 4 cells in a row. This is 6. This can't be 1 or 6. We are guaranteed an 8 here. 8, 9, 1, 5 adds up to, and we can't have 2, 4 here because of the 4 in the column. So it's 8, 1, 5, which eliminates 5 in the rest of the box. This is 6, 7 as a pair. This can't be 7 or 5. It's 3. This can't be 3 or 7. It's 5. 8 eliminates 8 here, so that's 2, which eliminates 2 here, so that's 8. Again, this can't be 8 here. So this can't be 2. We have 4, 8 here. This is 2, so this can't be 2 here. It's 4, 8 as a pair. Okay, remaining digits in column 9 are 1, 5, 6, 7. So this is 5, 6, 7. This can't be 5, so this is 1, 6, 7. This has to be 3, 6, 7 here, 3, 6, 7 here. 5 eliminates 5 from being here. This can't be 3 or 4. That can't be 1 or 2 because of 3 or 4 in the row. So again, this can't be 4 here. If this were 2, this would be 3, and this would be 1. If this were 1, this would have to be 2. So either way, this is 1 or 2. We have 1 and 2 guaranteed in one of these cells, so this can't be 1 or 2. This can't be 1 or 2. You could have 3, 4, 6, 7, 9. But this can't be 3 and 4 because that would eliminate both possibilities for this 5V. So this can't be 3. This can't be 4. This is a 6, 7 pair, which eliminates 6, 7 in the rest of the row. 6, 7's consecutive with 5, 6, or 7 here. We're guaranteed a 6 here. That leaves us as 3, consecutive with 2 or 4. We have a 2, 4 pair in the box, so this can't be 4. This is 3 and 9, which eliminates 3 and 9 in the rest of the box. This can't be 3 or 9. It's 1 and 4, adding up to 5. This is 2. This leaves this as 5, 6, 7. Again, it can't be 4, 5, 7, and 7, because that would add up to 23, but we'd have a duplicate in the tetromino. So it's 5, 6, and 8. 4, 5, 6 is 15, plus 8 is 23. That means this can't be 6. This is 7, which means it can't be 7. That's 6. That eliminates 6 here. 6 eliminates 6 here, so that's 2 and 8, which forces this to be 4. No 7 here. It's 5, 6, which forces this to be 7 there. 4, 8, and 7 add up to 19, with 4 adds up, well, it couldn't anyways. So it can't be, well, it would have to be 4, 7, 8, and 4, which obviously can't be in the same tetromino. So this is not in the tetromino. This must be a tetromino there. This can't connect because then it would be part of the same tetromino. So this is green, which makes this blue. These are not part of the same tetromino. These are not the same part of the same tetromino. It'd be too big. Did I mess it up? I don't know. I don't think so. 1 to 2 ratio cannot be 1 to 2, cannot be 4, so there's no 2, 4, no 4, 8. It's 3 and 6. 6 can't be here because of 6 in the column, so this is 3. This is 3, this is 6, which eliminates 6 here, so it's 5 and 6. 3 eliminates 3 here, so it's 9 and 3. We're guaranteed a 4 here somewhere. Three eliminates 3 here, so this is 1 and 4. 1 eliminates 1 here, so it's 2 and 1, which makes this 4 to add up to 5. 1 and 9 add up to 10. 1 eliminates 1 here, so it's 7 and 1. 9 cannot be here or here in row 8, so this is 9. So 13, we don't have an 8, so no 4, 9, no 5, 8. This is 6, 7 as a pair, so this is 6 and 7 because this can't be 7 here. 6 eliminates 6 here, so it's 5 and 6. 5 eliminates 5 here, so it's 3 and 5. Seven's consecutive only with 6 here. No 1 here. Remaining digits in column 6 are 1, 3, 4, 5, or 9. Only 4 is consecutive here, so 4 has to be one of these. It's only with 3 or 5. This can't be 4 or 9. This can't be 4 here. No 3 in the rest of this box. We have 4, 2, and 8 here. This can't be 2 because of 2 in the row. This can't be 5 because of 5 in the row. This is a 1-2 ratio. Cannot be 6, cannot be 1. So we're guaranteed a 4. This is 4 with 2 or 8. This cannot be 4, 2, 8 as a pair to add up to 10 because that would eliminate all possibilities for that cell there. No 3 and no 3, 7, no 4, 6 because of 3 or 4 in the column. So this is 1, 9. 1 again cannot be with any 4, 8 or 2, 4 to add up to 23. So this is 9. 9 and 1. So we have 2 and 8 here. 1 eliminates 1 here. So this is 9. This is a 2, 8 pair. This can't, 2 eliminates 2 here, so that's 8, which eliminates 8 here, so that's 2. This has to connect to an 8 to add up to 23. So this must be the 8 here, which means these are not shaded. 9 eliminates 9 here. We have 1, 5, and 7. We have 3 cannot be any of these cells, so 3 has to be here. That leaves this as a 5, 6 pair. We have 5, 6, 7 remaining here. So this can't be 5 or 6. It's 7, which forces this to be 5 or 6. That eliminates 5 here, so it's 4. This is 1, 5, 7 as a triplet. No 5 here, no 1 here. 3 and 6 add up to 9. 23 minus 9 is 14. 2 digits adding up to 14 must be 5 and 9. So we're guaranteed a 9 here. This can't be 4. We have 2 or 8. Therefore, we need a 4 here. No 4 here. This is 2 or 8 here. This is 2 or 8 here. Remaining digits are 1, 2, 7, 8 in column 4. No 1 here. Remaining digits in column 2. We have 3 and 8. Remaining digits in... I'm not sure how I got a 5. Yeah. Anyways. Remaining digits in column 3. 2, 5, 6, or 7. No 6 here. No 2 here because of 2 and 6 in the row. 5 and 9. 9 cannot be any of these digits. Cannot be here, so this is 9 here. Okay. Remaining digits in column 5 are 2, 5, 7, 8. How did I eliminate? Yeah, I don't know. It was weird. We have a 5, 6, 7 triplet in row 4, which eliminates 5, 6, 7 in the rest of the row. So this can't be 5, 6, or 7. It's 3. 3 eliminates 3 here, so it's 8 and 3. No 3 here. No 8 or 5 here. So this must be 1. No 1 here. 5 is one of these 2 digits here. So this cannot be 5 here. Because this is 6 and 7. Hmm. Yeah, I'm not sure how I closed this down. That was weird. Hmm. Okay. Um, one of these is guaranteed to be blue. 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 Hmm. Um, hmm. How did I get that was 8? That's so weird. I don't know how I got that. That's strange. I think that was the error that I was running into. Well, I mean, we could try that then, if that's 8. Yeah, I think that was the error. Hmm. 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 Okay. One thing is, so if it tries going this way, yeah, I don't know how I think I just messed that up. I don't know how I got the 8 here. That was the problem. Um, I think hmm. We're guaranteed one of these two is blue. So if this is blue, then this has to be blue. So obviously this has to be blue no matter what. You cannot connect this to this blue. So it could go blue here, but it can't connect there because then that would be way too large. It'd be 5. So if the blue can go here, but it definitely has to go this way because they cannot go blue, blue, or blue, blue. And then, so it goes 1 at most here. That's 2. We need another one. We need a 4th cell. So it's guaranteed to go blue there. That means these cannot connect here. If this is connected, that would be a 5 size Tetromino. So it could go here. It could go here. It could go here. If it were, again, if it were to go that way, I don't think that works, right? How about if it goes this way? I don't think that works either. Right? 2, 5, 7, 8. 5, 7, 8 adds up to 20 plus 2. Right, so it cannot be the full set there. It has to be then this. So this is the full blue here. This is then green. This is green. That's interesting. So it cannot be 2, 8, 2, 8, 4 because that requires a 9 to be with it. This has to again be 5, 7, 8 with 3. So that eliminates 5, 7, 8 in the rest of the box. This can't be 5. That's 1. This can't be 1 or 5, 7, or 7 or 8. So it's 2, which eliminates 2 here. So it's 8, which makes that not 8. So that's 2. So this cannot be... How does this work? It forms another... This is touching. Uh... 2 eliminates 2 here. That makes this 2 here. 7 can't be here. One eliminates 1 here, so this is 5, which makes this 7. That makes this 2. That makes this 1. 8 eliminates 8 here, so it's 7, which eliminates 7 here. That doesn't work. You could have blue go that way. Okay, so that doesn't work. So then I think you have to have blue go this way. Right? Which means we're guaranteed a 7 here. So it's either 2, 7, 5, which is 14, which would need a 9, and that's not 9. Or it's 2, 7, 8, which is 17, which would require a 6. So that does work that way. Okay, so then that's the case. This has to be green. These are both green. This is green because it's, yeah, this is the size. This is green. So this must be blue and blue here. This cannot be blue here. It's green, so this must be blue here. Okay, so then this is the shading. Okay, I don't know. Yeah, I'm not sure how I did that anyways. This has to be 6 with 2, 7, 8 to add up. So this is 6, which means this can't be 6. This is 5, which eliminates 5 here, so it's 6 and 5. 4, 5, 6, and 8 add up to 23. 5 and 6 eliminates 5 and 6 here, so it's 7, which makes this 2. 7 eliminates 7 here, so it's 6 and 7. This is 2, 7, and 8, so this is 5, this is 8. No 2 here, no 2, 5 here, no 7, 8 here, no 7, 8 here. Okay. This 5 is part of the 9. So this is 5, this is 1, this is 2, this is 5. 2 eliminates 2 here, so it's 8 and 2. I don't know how I messed it up. Anyways, 8 eliminates 8 here, so it's 7 and 8. 7 eliminates 7 here, so it's 1 and 7. I don't know how I messed that up. Yeah, that was weird. How did... So it was this part that was the problem, right? 8 was fine. I don't know how I got a... I think I got a 5 there, which I don't know how I did. Uh, okay. So it was this part that was the error here. This part was fine. I derived the 8, essentially, anyways, but, yeah. Apologies. Made so many well, just made that one mistake, I guess. I just proved that you can't have it this way. I proved that you can't have it this way here. So it has to be that way then, right? I don't know. Just, yeah. Kept on making a mistake. I'm not sure how. Pretty cool puzzle. I like the idea. Unfortunately, I did not execute it well. And I don't even know how I messed it up. Anyways, I hope you enjoyed the solve either way, and I'll see you next time on Frank Puzzles. Take care.